The European Space Agency's Earth Explorer program has seen several high-tech satellites play their part in our understanding of the global climate.
We have launched 3 missions, meanwhile, with fantastic results and very innovative technology.
SMOS, the Soil Moisture and Salinity Satellite, observed soil moisture over the land and salinity in the oceans. Cryosat, the ice mission, measured the thickness of the massive ice sheets over Greenland and Antarctica and the marine ice in the Arctic. It used a sophisticated stereo radar system and has helped give us a better understanding of the relationship between ice and global warming. GOCE measured Earth's gravity field with unprecedented accuracy. A geoid model is crucial for deriving accurate measurements of ocean circulation and sea level change, both of which are affected by climate change. This data revealed the Earth to be lumpy and quite variable across the planet. It has led to a new map of the boundary between the Earth's crust and mantle. Another piece in the climate puzzle, and a critical one, is the Earth's magnetic field.
The Earth magnetic field is our lifesaver, there is no doubt about this. This shield is basically protecting us from the harmful effect of the solar wind, these high energy particles that the sun is constantly bombarding us with, and this shield is really essential for us and for our protection. The main magnetic field of the Earth is changing in time, and it is weakening by a factor of, let's say, 10–15% or so over the last 200 years. And what's actually going on in the outer core of the planet is what we really try to find out. The magnetometer package on board SWARM, it measures the magnitude and also the direction of the Earth magnetic field. And it does so in 2 locations. One, it has an instrument at the tip of the boom and also another instrument halfway down the boom. And together, they give all this precise information that we needed to decipher the secrets of the Earth magnetic field.
ESA is now developing a new family of missions called Sentinels as part of their Copernicus program.
It is not sufficient to monitor the evolution of the ice cap or to monitor the sea level rise during 5 years and then stop. We really need to monitor those things over a very long time period. And this is what Copernicus will bring. It will bring a long-term frame for continuous monitoring of our environment.
Sentinel-1A is the first of a 2-satellite mission that will scan land and oceans using advanced radar to deliver imagery regardless of weather.
Copernicus is the most ambitious Earth observation program to date. The European Space Agency is putting together 6 families of Sentinels that will take care of the objectives of the Copernicus program, monitoring the land, the marine environment, the atmosphere, climate change, and providing a fast response to security and emergencies.
In total, there will be 6 Sentinel missions, each pair of satellites devoted to specific observations.
Each Sentinel has a specific duty. Sentinel-1 is more specifically tailored to emergency response. Sentinel-2 is focused on monitoring of the land. Sentinel-3, together with Sentinel-6, is focused on the monitoring of the ocean and waters. Sentinel-4, together with Sentinel-5, is specially tailored to the monitoring of the atmosphere.
The International Space Station is also host to several climate sensors. Currently, the CATS, or Cloud Aerosol Transport System, is mounted on the Japanese experiment module. Using light detection and a ranging LIDAR system, it detects and measures pollution, dust, smoke and other aerosols in the atmosphere. NASA will be installing another instrument, the RapidScat, onto the end of the station's Columbus module this year. It will measure ocean surface wind speed and direction, and help improve forecasting and hurricane warnings. The Orbiting Carbon Observatory was NASA's first satellite dedicated to the tracking of carbon in the atmosphere, how it is reabsorbed into the biomass, and where. Unfortunately, a launch failure has caused a reschedule of the project.
But we need the measurements that spacecraft like OCL will make in order to understand the processes controlling the rate of buildup of carbon dioxide in our atmosphere so that we can understand how it will change in the future.
Other projects in motion include the Atmospheric Dynamics mission Aeolus with its high-power UV laser, which will measure wind speed, air moisture and dust particles to advance our understanding of atmospheric dynamics. EarthCare will study how the Earth reflects and traps heat. Biomass will study the state of the Earth's forests. NASA's Clario satellite will measure incident solar irradiance and the Earth energy budget. SMAP, the Soil Moisture Active Passive, is an Earth satellite mission designed to measure and map Earth's soil moisture and freeze-thaw state to better understand terrestrial water, carbon and energy cycles. The suite of satellites now in orbit and planned for the near future will be able to peer beneath the clouds, vegetation and other surface features, monitor water salinity, temperature and energy fluxes, chart ocean currents and the change in ice caps. All this data is helping to improve our understanding of climate change and also helping in a practical sense, with flood and drought monitoring, hurricane and cyclone warnings, understanding changes in water availability, food production, and the other societal impacts of climate change.